Back in November of 2014, I made a video about building a VGA monitor out of leftover TV parts, and I'm going to see if I can do a follow-up on that. I have some footage of some more builds, but I was not happy at all with how that stuff turned out, so I'm not sure if I'm going to be able to make anything that makes much sense, but I'm going to do my best. And the boards I was going to be discussing are these little $5 or $6 universal VGA boards that I get off eBay directly from China. And I've used several of them now, and no two monitors were alike. I had to do a lot of special reconfiguration for most of the ones I built because I was working with unusual hardware. These boards were more designed for smaller panels than what I was working with, but I was able to use them regardless. And I'll show a few examples, one of which is quite a bit more time consuming than the others, but you'll get to see the outcome of each type of panel. And I apologize that the video is kind of all over the place and I seemed really out of it, because I was very tired when I did this, and it was actually I think a month or two ago now that I filmed most of this stuff, and I'm just now getting around to finishing the last couple projects I was building with these boards, and I'm going to attempt to make some sense of it and upload it. And at the end, I'll see if I can find some technical documentation on those boards so that you guys can see where they came from, what the model number is, things like that, and maybe some other information, but I'll have to wait and see what I can find. I'm going to use this 37-inch Magnavox TV as my first example. This is pretty much identical to the 42-inch Vizio that I used in my first video, because it's got an LG panel in it that has, I think it has all the identical hookups and specs and resolution and everything as that 42-inch panel had. I'm also going to do the same thing where I use the existing power supply from the TV to run it, because it's got the 24-volt backlight inverter again. I was really surprised how heavy this TV is. It actually weighs more than that 42-inch Vizio that I took apart last week, and this is only a 37-inch, so I don't know if they put some sort of reinforcement plate in here or what they did, but this thing weighs a ton. It's a model number 37MF331D37, made in November 2006. So let's get this back cover off and see if the power supply is going to be useful or not. I'm kind of disappointed to see that this is one of those TVs that has one box to hold both the power supply and the main board. It's going to make it a little more physically difficult to work with, because I've got to have the main board inside this box in order for it to hook up to the power supply, unless I just leave it laying off to the side or something temporarily while I'm testing. But other than that, it's pretty familiar. It's got the same dual inverter setup, and I'm pretty sure the connector pin out here is exactly the same. And again, you've got the ribbon cable going over to the master inverter. Notice the small ribbon cable that the Vizio had is not present. It's just a different setup. Normally there was another ribbon cable that went up over to the T-Con board, and this TV does not use it. In fact, there's the socket for it right there. Here's a look inside the board cage. We've got the power supply here, and the main board with its massive heatsink over here. I can't believe how large some of these boards are and how much heat they produce. They had to use this big heatsink to cool all the main chips and also part of the DC converter section. I'm going to be taking this out, and I'm really hoping that the pinout is labeled on the other side of this power supply board. Otherwise I'm going to have to use my meter and figure out the pinouts on my own. I don't think I have the service manual for this TV. Well, with the size of these BGA chips on here, it's no wonder they needed that big heatsink. These things are huge. I think they're even bigger than a socket 775 processor. Well, unfortunately, the power supply pins are not labeled on the other side of the board, so I'm going to have to figure out the pinout on my own. Usually it's pretty straightforward though. You're going to have several pins that are connected together that are going to go to ground, which is easy to find because you just got to find the one that has continuity to the one of the screws. And there will be a standby voltage pin, typically 5 volts, and that's easy to find because that's the only pin that's going to have voltage on it when the power supply is just sitting idle, but it has AC power connected to it. For the positive voltage outputs that run the main board, those also will usually have more than one pin connected together in parallel, and I'm thinking it's going to be the ones that come off this choke coil here. I'll have to use my meter to verify once I've got this powered up. There's also going to be 2 or 3 pins that don't go to anything on this board, but they just pass from the main board, you know, and then they go across and go right to the inverters. So you know that those 2 or 3 pins are not going to have anything to do with the power supply. So that really basically rules them all out. You got ground, positive output, standby, and the power on pin, and then 2 or 3 wires that just pass straight to the inverter. So I'm going to get a piece of paper and my meter and start checking these to see what's what. Well, after looking at this for a bit, I found that this isn't quite what I was hoping. This is one of those power supplies that does not use a standby circuit and a power on pin like that Vizio had. This just runs all the time, and it actually puts 24 volts out to the main board. And then the main board has several voltage converters on it that step down to whatever voltages it needs. And of course it provides the 24 volts to the backlight inverters. Alright, I've got all the wires traced out that I need to operate the inverters. So I've taken out 3 ground wires, the on-off signal and the brightness signal. Now, at first I couldn't figure out where the on-off signal was routed through because I couldn't get continuity from this connector to this one on any pin. But then I found out that the on-off signal is actually controlled by one of these little transistors over here. So I may have to bypass that and directly connect those 2 pins together in order for that to work with my new control board, but I'll find out after I hook everything up and test it. Well, I just had a setback to this project. Forgot to unplug the AC adapter when I was working in here and got distracted and ended up shorting this board out on a standoff on this metal case here and toasted this board. So I've got one left, and it was the first one I had ever gotten from my test kit. And I've also got to find a resistor big enough to use as a dummy load for this power supply because it does not run stable without a load on the 24 volt output that goes to the main board. But what I ended up doing was that power on line that I was talking that went into a transistor over here, that actually turns the power supply for the inverters on. Apparently there's 2 separate outputs on here, and but I did get it set up so that when I turn on the control board it would turn on the inverter supply, and it worked exactly like it was supposed to. The only problem I ran into was, for one, I burnt that board out, and for 2, like I said, I need to get a load for this. One thing I could do is put a DC converter on that 24 volt output to bring it down to 12 and run the control board directly off that like it would normally be run. But I don't have that stuff on hand right now either, so I'm probably going to have to wait a bit on this. How you like that dummy load for that power supply? Whatever works, right? Well, I powered this up using my test board, which is slightly different than the other board I used for that Vizio panel, and it does work. I got the no signal message on the screen. You know, of course I don't have the VGA hooked up, and it's powering the inverter properly. So I'm going to wait until I get a replacement for the board because I want it to be the same version as I was using on the Vizio panel, and I'll give it a full test. But so far so good. Okay, moving ahead a bit on this project finally. I've got the correct LVDS cable and a new board, and I ended up putting a DC converter in to supply the 12 volts. I totally forgot that I had these. It's like a modern replacement for a 7812 linear regulator, but these can supply 1 amp of current, which is enough to run everything. I think the panel uses a max of 600 milliamps, and I know the board hardly uses any, so it should be perfectly fine. And that way it makes everything much more simple. And for me to remove this board isn't much harder really. I've just got to cut one zip tie and unplug the connector over here and take this additional circuit out with it. So I'm ready to put this back together and give it a test run on the computer. I haven't got the long cable for the adjustment board yet, but I might not even bother. For now it's just mounted on the outside of the cage there. And I've got the VGA plug, you know, stuck on here as good as it's going to get. I don't have a piece of metal to make a proper plate for that yet, but this will work. It's not going anywhere. So anyway, let me get this reinstalled on the panel and hook this up to a computer. Alright, we're up and running. However, the on-screen display is currently in Chinese, and the picture is very dim because I have not adjusted the dimming on the inverter yet. So I'm going to keep it on its side so I can reach this adjustment board. Hold the menu button down for a few seconds. Should bring up the service menu. Alright, good, that's in English. At least I can find my way around on that. So let's go up to backlight and bring that up. There we go. Good enough. Alright. Now, picture's brighter. Can power that off. Turn it back on. Now I gotta get the menu changed over to English. So press menu. Go to where it says OSD. And the top item there is the language selection. So all we gotta do is go up to English, press menu again, and here we are. Okay. And there you have it. 37-inch, 1366 by 768 display. These big ones are kind of difficult to work with because of the physical size and often unique power supplies that they use. So now I'm going to get out some smaller panels and try those out for a change. It's hard to believe the difference in color quality between this big IPS panel and this TV versus the smaller screen in the laptop, which is probably a TN panel. I believe it's an LED backlight, but this whole screen has kind of a bluish haze to it, you know, and the colors are not very vibrant. It's just kind of dull. It looks okay, but it's really, I don't know, just really hazy and cold looking. And then you look at this screen here, and it's really a vast improvement in the color gamut. You know, I haven't even done any special calibration or anything on this. This is just a pretty much out of the box setting here, set to the warm color preset in the menu, and I'm just amazed that this old screen looks this good. If I can, the camera really doesn't do it justice. Yeah, the camera doesn't really show that big of a difference, but I tell you, in person, it's huge. This screen's got great color. But like I said, let's move on to some smaller panels now. Another question I was asked in the previous video was whether or not these universal LCD driver boards would run an LED backlight. And the answer is yes, as long as you have the proper cabling and DC converter board for whatever panel you're using. This panel here uses the 12-pin miniature ribbon cable type connector for the backlight, and the LVDS connection is exactly the same. It's the 30-pin connection with 5-volt supply voltage. The DC converter board plugs into the exact same connector that the CCFL inverter board would normally plug into, so it works exactly the same way. This panel is actually out of an old ViewSonic monitor. It's a 22-inch 1080p panel. So I'm pretty much running this driver board at its limit at 1920 by 1080, and I'm using a cheap, really thin VGA cable and just have the board laying on the bench back here so it's not shielded. There is a slight bit of softness to the edges of the fonts and stuff, but to be honest, it looks really good for what it is. And if I had this properly assembled and had a better cable, and not to mention something better than this old onboard Intel video, it would probably be even sharper. I was actually thinking about using this particular panel with a better driver board, something that's got HDMI and DVI on it. You know, since this is 1080p with an LED backlight. But I don't know, this panel's in kind of rough shape. It's got some scuff marks on it. And I don't know if I want to spend $30-something on a higher end control board kit or not. But yeah, that's just one more example. I'm going to see if I can show a couple other setups here in comparison. Here's another example of where I was able to reuse the existing power supply board when replacing the bad main board with one of these universals. Another little trick that you can use if you have a monitor like this that has a 5-volt panel and the power supply in the monitor is designed to have most of its load on the 5-volt rail, you can still use it. And the way you do that is you run 5 volts into this board and then set the panel voltage jumper to the 12-volt position. And basically what that does is it just connects the switching circuit that supplies the panel voltage directly to these power input pins on this board. And you know, since even though you've got it on the 12-volt position, you've only got 5 volts coming in and it's going directly to it, so the panel is still getting its required 5 volts to operate. And these two linear regulators on here are perfectly happy with 5 volts coming in as well, so everything works normally. Because this power supply in particular, when you try to run everything on the 12-volt rail and then let this do the voltage conversion to run the panel, it's too much load for this rail and there's too much noise and ripple, so you end up getting little hum bars in the picture, and that wasn't good. So I ended up improvising again in a different way, like I said, and just using 5 volts to supply this and in turn supply the panel. And it works perfectly fine. In fact, it looks very nice. Nice and clear. But anyway, I think that's enough examples for this. I'm going to head upstairs and we'll take a look at some documentation and some data sheets if I can dig up some more useful information on these boards. Well, there's not much information available online about these particular boards, but the company that makes them is SAQCN. I'm not really sure how you'd pronounce something like that. And on the page here they show the model SQM007. I think it's the same thing as what I'm using, but this also has the wireless remote receiver circuit on it, and mine does not. I think mine is the SQM005, even though the PCB is marked 007. At least I'm pretty sure it was. But I have the manual here on the screen, and it shows the jumper table. My only real complaint with these boards overall was that it could not run any of the 1280 by 768 resolution panels that I salvaged out of some laptops. It only has 1024 by 768 or 1280 by 800. There's no 1280 by 768. But the only thing I was able to use this manual for was to find out how to get into the service menu, which in turn allowed me to adjust the backlight dimming voltage. Other than that, the documentation didn't help me with much because I was using these boards for things they weren't designed to be used for and had to figure things out on my own for the most part. But I wish I had more things I could build with that, because I don't think my examples that I used were explained very well. And I wanted to do a better job at it, but I'm stuck now. I'm out of things to put together. I don't have any more panels to experiment with, so I've just got to work with the footage that I have, and hopefully it's going to be good enough to help somebody out. And if anybody's working with those boards, you'll be able to see what some of the capabilities are, even if they're not really designed for that. Another thing I'm going to do, since I'm running these boards in a situation where they're going to be working pretty hard, is I'm going to add heat sinks to the main IC here. I have some RAM heat sinks that were actually designed for some video cards, and they're the perfect size to fit that chip. So I'm going to use some thermal epoxy and just epoxy some heat sinks on there to extend the lifetime of these boards, because that chip does get pretty warm under operation. And when you're running an enclosed cabinet like I'm using and running 24/7, they're probably not going to last as long as I would like. So I think before I really put them to use full time, I'm going to add heat sinks to those chips. But I really like how simple these boards are. I mean, there's just a couple of voltage regulators, the clock crystal, the main chip, and the EEPROM. I mean, there's nothing to it really. But anyway, I'm going to try to edit this video together and get it done. I'm glad to finally be able to wrap this project up 3 months later. 3 or 4 months. But yeah, time to finish it. I'm browsing eBay looking for more of those same boards that I have, and it doesn't appear that there's any for sale right now. The only ones I've found that use the same controller chip are these little square ones that are only designed for 5-volt panels. I think they'll do 3.3 also, but I don't believe that these will do 12 volts. But yeah, I don't know why nobody's got them for sale, but they used to be on all over the place, a few months ago. You just search for universal jumper LCD board and you'd find a bunch of them, for $5 to $7 each. But while I'm on here, I can find a couple examples of the larger boards to look at. Okay, here's a couple examples. This one's even got HDMI on it, and I've seen a lot of these around eBay. And the seller is Trusty High. I think I've actually bought from them before. I haven't tried any of these specific boards, but these are the ones where you have to give them the model number of the panel so they can program it for you. These are not the jumper type universal boards. And they show a list of all the different panels they can set the board up for. See another one here. That one's got VGA and DVI. Again, this is not a jumper style board. See if there's any on here that actually have jumpers. I know there's a couple of them out there, but it seems like most of the ones I'm finding are the ones that they have to program. And you can get programmers to set these boards up yourself for 25 or 30 bucks, and they actually hook up to the VGA port and either to USB or parallel port on the PC. But I haven't tried any of those myself yet. Let me see if I can find another board with some jumpers on it. Okay, here's an example. This has VGA and DVI and has a 4-position jumper to pick the resolution here, and also pick the signal type, single or dual, 8-bit or 6-bit, up to 1920 by 1200. It's not quite as many resolutions that the board that I have, but this one's got DVI, which makes it a little more useful for picture clarity. I'm not familiar with this seller here. I'm trying to think of some of the sellers I've used. China Tabi, Trusty High, NJY Platform, EQ Store, some of those Gold Part. Those are all ones I've bought from in the past, and I know they're pretty trustworthy. But yeah, like I said, there doesn't seem to be any of those specific boards for sale that I used in that video, which is unfortunate because I was looking for some more myself. But I think I got to wrap this video up, and hopefully some good came out of it.